Today, we're going to take a deep dive into Titan, the largest moon of Saturn, and uncover its extraordinary features that have captivated scientists and space enthusiasts alike. As one of the most complex moons in our solar system, Titan boasts a range of unique qualities that make it a compelling subject for further investigation. From its unusual atmosphere and liquid on its surface to its remarkable landscape, warm water ocean, and breathtaking rains, this celestial body is truly a wonder to behold. Throughout this video, we'll delve into each of these features in detail, revealing the science behind Titan's mysteries and exploring the possibility of life forms beyond our wildest imagination. So sit back, relax, and join us on this fascinating journey as we uncover the secrets of Titan, a world beyond our own that continues to surprise and inspire us. Titan, the largest moon of Saturn and one of the most intriguing objects in our solar system, has fascinated scientists and amateur astronomers alike. With a diameter of 3,000 to 100 miles, it is larger than Mercury and almost as big as Mars. Despite its size, it can be observed by anyone with a basic telescope. First discovered by Christian Huygens in 1655, Titan remained a mystery for centuries. It was only in the 20th century, when the Pioneer and Voyager probes visited the Saturnian system, that scientists were able to study this enigmatic moon up close. However, the images they obtained were obscured by a thick layer of haze, composed mainly of hydrogen and nitrogen. Renowned astrophysicist Carl Sagan was one of the first to suggest that Titan could be an exciting destination for scientific exploration. He theorized that the moon's surface temperature of -290 degrees Fahrenheit could allow for the presence of liquid methane, which would create a landscape of rivers, lakes, and seas, unlike anything on Earth. In 1997, NASA's Cassini spacecraft was launched on a mission to study Saturn and its moons, including Titan. The spacecraft carried a special lander called Huygens, which was designed to explore the moon's surface. In 2004, Huygens successfully landed on Titan and transmitted data back to Earth, revealing a fascinating world of hydrocarbon lakes, icy mountains, and exotic chemistry. Today, Titan remains a subject of intense scientific interest as researchers continue to study its complex atmosphere, geology, and astrobiology. With future missions planned to explore this remarkable moon in even greater detail, we can look forward to unlocking more secrets of this alien world. Did you all know this before? Stay connected because there is still a lot to watch. Titan's atmosphere and surface. The Huygens probe's descent onto Titan took around 2.5 hours. Due to the dense atmosphere, it had to float down using a parachute and spun so fast that many of the images taken during the process were unusable. It was discovered that Titan's atmosphere extends over 300 miles above its surface, making it the highest atmosphere in the entire solar system. The atmosphere is made up of several layers containing various substances and temperatures. The surface temperature is a frigid -290 Fahrenheit, but it becomes much warmer at 200 miles, reaching a temperature of -130 Fahrenheit. At around 250 miles, the familiar orange haze begins to form, which continues down to 60 miles before clearing as the surface is approached. At about 30 miles high, the satellite's surface becomes visible, revealing a landscape that includes mountains and rivers. However, the orange haze layer is relatively opaque throughout, meaning that sunlight doesn't reach the surface. The surface of Titan is relatively flat with a texture that includes smooth, icy rocks resembling pebbles. The first image taken by Huygens upon landing showed these rocks in a dried-up bed of a methane river. However, subsequent images revealed no traces of liquid methane, prompting theories about where it could have disappeared, including the possibility of an underground ocean. Two theories have been proposed to explain the absence of liquid methane in the dried-up beds of rivers on Titan. The first theory suggests that these rivers undergo a climate cycle similar to Earth, where they are filled with methane rain and subsequently dry up again. The second theory proposes that the methane rivers were once fed by underground springs that no longer function. The Cassini probe is expected to collect further data during its 127 flyby missions in Titan's orbit, which will shed more light on this fascinating moon. Reasons why Titan's atmosphere is so opaque. We begin to decipher the reasons why Titan's atmosphere is so opaque. Titan's atmosphere is composed of multiple layers, each with unique characteristics. The first layer, situated over 300 miles above the surface, is where complex organic compounds are produced, making it the largest factory of its kind in the solar system. Methane, nitrogen, and hydrogen are transformed into more complex elements before descending toward the surface, creating a new layer. The second layer, located between 200 and 250 miles above the surface, is comprised of a thallium haze, similar to soot produced by combustion on Earth at around 200 miles. The third layer begins, consisting of the inner gas ethane. Interestingly, scientists observed a unique anti-greenhouse effect on Titan, where the thallium haze and ethane act as a shield to maintain both the heat from the sun at an altitude of 250 miles and the cold temperatures near the surface of -290 Fahrenheit degrees. Titan even has some clouds, although very few. Despite rapid climate changes, a recent tropical methane storm was recorded around the equator of Titan, with methane raindrops the size of a pear descending slowly from the sky. The Huygens and Cassini probes confirmed the atmosphere's composition, with nitrogen being the dominant gas and 3.5% methane present. However, the most intriguing aspect of Titan's atmosphere is that its chemical reactor is located at an altitude of 300 miles, resulting in huge amounts of organic compounds descending to the surface over time. This process is similar to what occurred on Earth over 4.5 billion years ago. The only difference is that Earth was warmer due to its proximity to the sun, and the organic substances that fell from the sky did not land on a methane soot surface or liquid methane oceans. The first hint of potential, albeit primitive, life on Titan. Upon analyzing the layers and composition of Titan's atmosphere, scientists stumbled upon another mystery. Despite calculations suggesting that the methane in the atmosphere should have dissipated 10 million years after its formation, it has persisted for over 4.5 billion years. This begs the question of what is replenishing the methane levels in the atmosphere. Some scientists propose that the vast amounts of methane present during Titan's formation have yet to be exhausted. Alternatively, methane may be generated by chemical reactions occurring on the Moon's surface or potentially produced by living organisms as part of their metabolic processes. The second mystery of hydrogen in Titan's atmosphere. Scientists were confronted with a second mystery concerning the abundance and distribution of hydrogen in Titan's atmosphere. The hydrogen levels were supposed to be 2.5 times lower than observed. Furthermore, it was unclear why the distribution of hydrogen was uneven. Hydrogen content was found to be less at the surface level than expected, while the amount increased twofold as we move closer to the top. These findings prompted scientists to consider the possibility of biological processes utilizing hydrogen, leading to a shortage of hydrogen at the surface. The surface of the Moon. Let's turn our attention to the surface of the Moon for a while. The surface of Titan has an uncanny resemblance to Earth, as revealed by a photo taken using the VIMS camera. The topographic map captured using radar further reinforces this similarity. However, the absence of meteorite impact craters on Titan is a puzzle for scientists, as it reduces the chances of determining the age of the relief and assessing the degree of geological activity. While the lack of craters can be attributed to the dense atmosphere, the number of craters is still too few. This raises questions about whether Titan has tectonic plates like Earth and how active its surface is. Additionally, its surface is remarkably smooth, further adding to the mystery. Titan without the atmosphere. Let's take a look at Titan without the atmosphere. The dark areas on Titan's surface initially piqued the interest of scientists who believed they might be oceans of methane. However, when the Huygens probe landed in one of these areas, it found no liquid. Further examination revealed that these dark spots are actually deserts, formed by similar processes as those on Earth. Titan's climate system, with its own seasons and wind patterns, led to the formation of a dune system made up of tholin, soot, and organic substances. The low gravity on Titan means that even a wind of just 11 miles per hour can create a dust storm. While the sand on Titan is organic in nature, its origin remains a mystery. Initially, scientists believed it was formed from remnants of methane that fell from the sky during rainfall, with the methane carrying soot down to the surface as it evaporated. However, since it rarely rains on Titan, the prevailing theory now suggests that the sand simply falls out of the tholin haze directly onto the surface, akin to snow covering the satellite. Searching for the liquid. After studying the first pictures that showed the beds of dried-up rivers, the scientists set about searching for the liquid. The first methane lake, Ontario, was found at the south pole of Titan. Although it is the only lake remaining in that area, several dried-up lakes have been found in the vicinity. Scientists are still debating the composition of their shores and what may be at the bottom of these lakes. In contrast, the North Pole is home to entire seas, with rivers flowing into them. The Kraken Mare and the Ligeia Mare are unique features within the solar system, as they are the only places apart from Earth where liquid has been discovered on the surface. Whether this satellite can sustain life. The main mystery is still the answer to the question of whether this satellite can sustain life. Titan, a moon of Saturn, has two potential perspectives for the existence of life. Cryovolcanoes have been discovered, indicating the presence of a warm water ocean beneath the ice crust, which is sandwiched between two layers of ice. Although Titan is much colder than Earth and has no water or oxygen, life may still be possible there. Methanogen bacteria could exist and feed on hydrogen and acetylene, producing methane as a result. However, methane and ethane do not behave the same way as water in supporting life, and the cell membrane may not be suitable to protect and filter the cell's contents. Recently, Chinese scientists synthesized ozotosums, organic compounds that could form a protective membrane for a cell in a methane environment. Observations through ALMA telescopes revealed the substance that would protect a living cell on Titan can be created in large quantities, supporting the possibility of life. Despite skepticism, an unusual asphalt lake on Earth composed of natural asphalt, petroleum, and complex hydrocarbon compounds yielded samples containing millions of live anaerobic bacteria that feed on hydrocarbons and break down crude oil. Life on Titan may be diverse and similar to life that originated on Earth 4.5 billion years ago. Future missions to Titan are essential to unravel the mystery of how life arises, but enthusiasts can observe the moon through telescopes with keen interest as a cold but living mirror of Earth's past. This was all about today's video. See you soon in the next video. If you enjoyed this video, we would love to hear how much you enjoyed it. Feel free to leave a comment. Be sure to subscribe to the channel so that you can see more awesome videos like this in the future. Thank you.